Maths Aspirants is a community of math lovers, students, teachers, and research scholars, started by myself in 2017. And we used to arrange online problem solving session and test series to help the students who prepare for different national competitive exams like CSIR-NET, GATE, IIT JAM, NBHM exam, and other PG entrances, etc. As a part of these online problem solving sessions, today we have a session on basics of ordinary differential equations. And the session will be handled by Ms. Unnati Shukla from IIT Dhanbad. Ms. Unnati is currently pursuing M.Tech in data analytics at IIT Dhanbad. She has done her M.Sc in mathematics and computer science from Maharshi Dayanand University, Rohtak, Haryana. She qualified IIT JAM with All India rank 31 and CSIR-NET with All India rank 39 and GATE examination with All India rank 77. I'm sure that today's session on basics of ordinary differential equation will be really a fruitful session and will be really helpful for those who prepare for different competitive exams. I would like to express my sincere thanks and gratitude to Ms. Unnati for being with us, and I welcome everyone to this program. Welcome, Unnati.
It's a great opportunity for me, and I feel very grateful to be a part of this community and being able to impart my knowledge to a large number of students. So today we are going to discuss about ordinary differential equations. It's some basics, and I'll also be covering a topic which is less known by students and which really helps in competitive exams. And so I hope this session helps you. And this session is going to be focused more on attempting questions in competitive exams and also clearing your basics regarding this subject. So I hope this helps you. So let us begin. Before starting with ordinary differential equations, there are three words: ordinary, differential, and equations. We have a little bit of idea about these three words, but before starting with this, I would like to cover the definition of dependent and independent variables. What do we know about dependent and independent variables? So we all have studied functions, right? We've studied functions like y is equals to f of x, where x is the independent variable and y is the dependent variable. If x is a function of y, then this y will be independent variable and x will be dependent variable. So it doesn't matter. So if y is a function of x, we say that x is independent and y is dependent. So the dependent variable is that particular function. So we have studied functions. Now we also will take the help of functions, and with the help of these functions we'll make equations, and with the help of equations we'll be seeing differential equations that relates to our real life problems, and we will be trying to solve these differential equations to help in our real life situations. So this particular subject of mathematics is related to applied portion, which is related to more solving of real life problems. So we know what a dependent and independent variable is. Now, you've also seen functions like f of x1, x2, up to so on, xn. I mean, there can be more than one independent variables also. There are n independent variables. You've also seen functions like this. And you've also seen functions like y1 is equals to f of x1, f of x2, up to so on, f of x1. So there can be many functions dependent on these n variables, these exact n variables. So it totally depends on in which dimension we are talking about. Usually we have one dependent and one independent variable, because ordinary differential equation relates to, I will be covering this in the type of differential equation. What we are going to study in the topic for IIT JAM, GATE, and CSIR-NET. This is not all we have to study. So the topic that IIT JAM, CSIR-NET, and IIT JAM covers is a very small topic. So we should have an idea. Now there's one thing also which is called total derivative. Total derivative. My pen is creating a little bit of problem. Total derivative and partial derivative. Suppose you have a function y is equals to f of x1, f x2 up to so on with n independent variables. If you take the total derivative, that means you're taking the derivative of this y, this variable, this function, with respect to all the independent variables. For example, when you take the total derivative, you write it like dy is equals to del y over del x1 into dx1, and this process continues up to del y over del xn into dxn. So this is about taking the total derivative. For example, if I am sitting in my hometown Rohtak and I want to reach out to your place, so how much time will I take to reach out to, maybe you would be sitting in Ahmedabad, or maybe you would be in Kerala, or you might be in some city of West Bengal like Kolkata. So how much time will I take to reach at your place? Now your answer will be, it depends, right? It depends whether it will take 1 hour, 2 hours, 10 hours, 20 hours, depending on the distance of the distance between the 2 points, maybe from Rohtak to Ahmedabad, Rohtak to Kerala, or Rohtak to Kolkata. So it depends on the distance and also my speed. For example, if I travel with 20 kilometers per hour, it's going to take a lot longer time. And if I'm going to increase my speed, it's going to take less time. That's what we have studied in earlier classes. So the time variable is a function of, you can say, function of distance and speed. So speed and distance here are two independent variables, and time in this case, the question that I've asked, the problem that I've given you, how much time will I take to reach out to your place? In that question, time is a dependent variable. So these are the things. Now, what is partial differentiation? If I talk about only what time I'm going to take to reach out to a place, depending on the distance, just depending on the distance. So I'll talk about the change, my change in time with respect to the particular distance that we have. So this is very basic idea of what we study in differential equations and how it reflects our own real life. So this is a great subject, and it has many applications in different areas of mathematics, and also engineering students study this subject, also physics students. So it has a wide range of applications, and most of the math students, math subjects have wide range of applications. So this is one of those subjects. Now I'll dive deep into directly into the definition of differential equations. So let me just take it out. So what is a differential equation? Now you can see on your screen a differential equations. So we say if y1, y2, yn, there are n dependent variables, and there are n independent variables also. if there are n dependent variables and n independent variables. It could be 1, 2, or n. It depends on the question. Okay. So this is a very general definition of differential equation. You might be thinking we have studied only one variable. This is a very general idea of what a differential equation is. So there could be n independent variables, or there could be m or k, dependent variables. That the equation involving, they say that the equation involving independent variables, dependent variables, and the derivative of dependent variables with respect to some independent variables. In ordinary differential equations, we have only total derivatives. So I'll give you a brief idea about it. Suppose you have a function y is equals to x squared. How do you differentiate it? You find its total derivative dy by dx, and in case of one variable, one independent and one dependent variable, there is only when the independent variable is only one, there is only a total derivative. So in this case, you will find dy by dx as 2x. But this is the very basic idea of what a derivative looks like. So they say, in short, they say what a differential equation is. It contains maybe n independent variables, maybe k dependent variables, but it should also contain the derivatives of the dependent variables. In this case, it is y, and the derivative of dependent variables with respect to the independent variables. So for example, first example I take, dy by dx is equal to dy by dx plus mod y is equal to 0. Now this is a differential equation. Why is this a differential equation? Because we know from the statement, we know y is a function of f of x, or it could be, what happened? Yeah, y is a function of f of x, or in this case, it could be x is a function of f of y. That's completely okay. You could write dy by dx or dx by dy. That's okay while writing.
Ma'am, hello? Ma'am, you are muted. Hello.
Yes. Am I audible now?
Yes, ma'am.
Okay. I don't know why it happened. So we are studying a basic example of differential equation. Dy by dx plus mod y is equal to 0. Now y, as we see, it is a dependent variable, and we have the derivative of the dependent variable dy with respect to the independent variable dy over dx. So this is a differential equation. Now to give you an idea, let's look at some more examples. Now the second example says, if y is some function of x and t. Now there are two independent variables. Now in this case, you see del y over del x plus del y. We could also have more than one order partial derivatives. Del t square is equals to 0. Let's say this is our equation. So someone asks you if this is a differential equation. Yes, of course it is, because we have the dependent variable y and the independent variables x and t, we know. And the derivative of the dependent variable with respect to the independent variables, maybe it's x, or in the second term it is t. So x and t both are independent variables. So these are partial derivatives. So this means that this is not an ordinary differential equation, because as I told you, ordinary differential equations contains only total derivatives. So in this case, this is a partial differential equation. This is a differential equation, but it is a partial differential equation. Now let me tell you, not every equation is a differential equation. Now you might be wondering how. So for example, let's for the same function y is equals to f of xt, let's look at this equation. Y plus del x over del t plus del y over del x is equals to 0, let's say. It could be anything, but it is equal to 0. Now, this is not a differential equation. The reason being, I hope you might be able to figure it out, because I have taken the derivative of the independent variable with respect to another independent variable, and that's the cause of this problem. So this is not a differential equation because it strictly says that you can't derivate the dependent variable with respect to another dependent variable. So in this case, if you want to include the derivatives, then only you should have del y over del x or del y over del t. Or maybe their higher order derivatives, maybe second order derivative of this, or maybe second order derivative of this, right? So you can't include this kind of derivative. This won't be called a differential equation. Now you might have a clear idea of what a differential equation is. Now let's move on to another part of our lecture. If someone is having any little doubt, they can ask me now or at the later section of this lecture. At the end, I'll be taking all of your doubts, so you can note down your doubts, and then we will discuss it at the end of this section. So I have some more examples. I will give you a brief idea of difference between a differential equation and a non-differential equation. For example, I have this equation. Here y was a function of x. So this is a differential equation. It contains an integral. And another differential equation is dy by dx over, let's say, integration of f of x, t of x is equals to x. So now the first equation is something that contains a definite integral, and the second equation contains an indefinite integral. Now we have to judge whether these two are differential equations or not. In the first case, we can see clearly that this is going to be whatever, this is going to be a constant. Because when you integrate this function and you put the limits which are in constant, you are going to get a constant in return. So this is going to be something like dy over dx plus some constant k is equal to, there was some, let's say 0. So equal to 0. Now this is a differential equation. It contains a constant, and differential equations can contain constants because they are also functions. So they can be considered as a function of x. You have a differential derivative operator, then they're equal to 0. And in this case, this is not a differential equation. Well, it can be called a differential equation, but that's going to be a very particular case. You'll study that later. These kind of equations are called integral differential equations, but not the kind of equations that we are going to cover in our syllabus. So this is not a generally, this is a differential equation. We can't deny the fact that this is not a differential equation. But this kind of differential equations, we won't be dealing with this kind of differential equations. So you need to understand that this is going to be a sum function, but this is a derivative operator, and this is an integral operator, okay? And this is a function. This is the independent variable. So this will be called integral differential equations. We won't be dealing with these kind of equations. So you have seen, I've given you a broad idea of how differential equations look like. Now we will cover some more topics, and we'll also look at some questions. And I also have a bonus topic for you today, which is autonomous differential equations, which you will thoroughly enjoy because it covers great learning for you. So let's briefly cover the order and degree of the differential equations. Order and degree of differential equations. Keep noting down your doubts and whatever you find useful in this lecture. We'll discuss that at the end of this lecture. So what is the order of the differential equation? Well, whatever the differential equation is given to you, it is the highest order derivative. Order is actually the highest order derivative present in that equation. So what does that mean? For example, I have a differential equation. You can also write these derivatives as y double dash. You know, if you want to use a little bit of less work, you can use second derivative as y double dash, first derivative as y dash, y prime, sometimes we say. So let's say we have this differential equation. Okay, now someone asks what is the order of this differential equation. So your answer would be, what is the highest order derivative present in this equation? And we can clearly see that it is 2. The highest order derivative that is present in this equation is 2. So the order of this differential equation will be equal to 2. For example, if I raise it to power 7, what is the order of this differential equation now? It is still 2 because the order of the derivative is 2. When you raise its power, it is the power of the derivative, not the order of the derivative. So we will be dealing with these powers. What are these powers? And here, but these powers does not increase the order of the derivative. Order of the derivative is present, in its purest form here. We can also cover some more examples, like, for example, someone asks you dy by dx plus y triple dash x raised to power 1 over 5 is equals to 0. What is the order of this differential equation? Well, there is a 1 order derivative and there is this 3rd order derivative that is also present. So we will give preference to the 3rd order derivative because the order of the differential equation is the order of the highest order derivative. So we need to find out that highest order derivative. So for example, sometimes these derivatives are in this form, sine of this plus y is equals to 0. And in this case, you might be thinking that this is inside sine. So this is the angle of sine, but still it is a 5 order derivative. And also in this case, the order will be counted as 5. So it's very easy to look at the order of the differential equation. You just need to look at what is the highest order derivative that's present in the differential equation. But the degree of the differential equation, I will also give you some questions to practice if you ask me, because we have limited time in this lecture and I can't just cover all the questions of order, degree, and so on. And these topics are good for knowledge, but they don't come, they do not come in the exam of CSIR, NET, or JAM, or GATE, or mainly rarely in any exam. So they used to come in our maybe JE exam, but you should have a little bit of knowledge about everything. So let me take another differential equation to give you an idea about the degree of the differential equation. Well, what is the degree? It is the order of the, I will also be sharing the notes with you because I'm not writing the definitions in completely. So I'll also be sharing the notes with you after the lecture so that they might help you. So let me take this example. I have raised it to power 5 plus dy over dx raised to power 7 plus y is equals to, let's say, sine x. So this differential equation, what is the order of this differential equation? You'll say that it's 2, because the highest order derivative is 2. We don't care about the powers. We care about the powers when we are finding the degree, not the order. So what is the degree of this differential equation? Degree means the order of, degree is the highest power. You can also write it down, highest power of highest order derivative that is present in your differential equation. Highest order derivative that is present in the equation. So we have a 2-order derivative that is present in our equation. And when we raise it to power 5, that means our degree becomes 5. Okay. Why I have used highest power of highest order derivative? Because if you were given this differential equation, let's say this, A differential equation would be, it would be like this, for example. Now, what is the degree of this differential equation? Now, in this case, both orders are same. The derivatives of both order derivatives are same. So in this case, we will find the highest power. So highest power is 3 or 5. It's 5. So in this case, degree would be 5. And of course, you know that order is 2. So that is important to consider. And also there's one result. One more thing that needs to be considered. We can find the degree if your differential equation is free from radicals and fractions. So what does that mean? Let me give you an example for this. Let's say your differential equation is this, and this is raised to power 2 by 3 is equal to d cube y over d cube. If any one of you faces any audio issue, please let me know in advance so that I can fix it. So this is your differential equation. Now you are asked to find the degree of this differential equation. Now you will say the degree would be 2, right? But you can't directly find the degree like this because you saw that 2 by 3. Here the order of derivative is 2, but you need to find the highest power of the highest order derivative. So you will say, okay, so highest order derivative is 3 and its power is 2, so the degree will be 2. But you can't do it until you free it from fractions power like this. So how will we free it from this fractional power? We will raise cubing. We will raise 3 power both sides. So we'll do the cubing both sides. When you will cube both sides, you will get y double dash, I'm writing it in short, square is equal to y triple dash raised to power 6. Now you can find the degree because this differential equation is free from the fraction. Okay, now what will be the degree? The degree will be equal to 6, and you know the order is 3 in this case. So I'll give you one last example of how to free a differential equation from radicals. For example, you have a differential equation like this. Now someone asks you what is the degree of this differential equation. Now this differential equation is in radical form because you have this numerator and this denominator. You can't leave it like this because this is a derivative and it can't be in a fractional form in denominator. So what we'll do? We will multiply this denominator. We'll do the cross multiplication. So we will get dy over dx square is equals to 1. So now order is 1, which is clearly 1, and degree is 2 because dy by dx raises to power 2. So order becomes 1, degree becomes 2. I hope you all are getting a clear idea of what I'm teaching you. Please let me know.
Yes, ma'am.
Okay, thank you so much. Thank you so much. So let me move on to this. There's a little more on this topic, but let me move on to another topic, which is more important than this, because I have almost 90% covered your order and degree. There's one more thing left, but we'll see it in the end of this video, this lecture, if we have enough time to do this. So because this topic is not very important for the exam, that's why I've covered its basics. So now we will be studying linear and non-linear differential equations. So there are only 2 types of differential equations. Differential equations are only of 2 types, linear differential equations or non-linear differential equations. For linear differential equations, we have different ways of solving it. We have figured out some ways of solving it. Most of the linear differential equations can be solved. We have figured, almost all the ways to solve these kind of equations. But for non-linear differential equations, there are still some researches that are going on, because it has a wide spectrum spectrum of different kind of differential equations, and we can deal with some of them, but there are still many kind of non-linear differential equations which we are not able to solve easily. So in this case, research is going on, but for linear differential equations, we know many methods like exact differential equation method, or there is a first order, first degree differential equation. So there are many ways to solve these kind of differential equations. So we will study about what is a linear differential equation. You should have a clear idea of what a linear and a non-linear differential equation looks like. When non-linear doesn't have a particular kind of form, it can be of any form, but we have a particular kind of form for linear differential equations. Let me write it for you. A differential equation which is of the type, for example, you have a function y is equals to f of x. So if a differential equation is of type a naught x, what is a naught x? It is some function of x. A naught is some function of x multiplied by y. Y here is also a function of x, so you can write y of x or just y will do. Okay, that's not very important to write it because that's clearly understood that y is a function of x. Then you have this first order derivative of y, or you can write it as dy over dx, plus some another function of x. These functions can be same or can be different. So in general, they are not same. So that's why we have taken a naught, a1, a2. Now there is second derivative and so on. This continues to, maybe nth order derivative. So n could be anything. N could be 1, n could be 2, n could be 3. So it could be anything, is equals to v of x, another function of x. It could be any function of x. So let me write you and give you an example about how this works. Before that, let me tell you, it looks like a polynomial. You write a polynomial of a naught plus a1x plus a2 into x square. The only difference is that here a1 naught, a1, a2, you can write them as b naught, b1, b2. They were constants and they were multiplied by x. X's powers. Now what's increasing? Now the derivative powers and the order of derivatives are increasing. And do we have anything in the power of derivatives? Do we have some power of derivatives? No. When you raise to the power of derivatives more than 1, for example, if I raise it to the 2 power, that will not be called a linear differential equation. In that case, that will be a non-linear differential equation. So in linear differential equation, the purest form to write them as is like this. You have the derivatives and the derivatives are in linear form. That means they are not raised to any power other than 1. So for example, dy by dx plus 2 times of d2y by dx square is equals to sine of y. Is it a linear differential equation? That is the question. You might be wondering, is it or is it not? So if I compare it with the above general form, I can get a2 as 2, a1 as 1, and if I take it from here to here, sine y, I can say a naught is equals to minus, if I take sine y from right to left, what will be theirs? Now you easily can see that there can be y, there can be dy by dx, but there cannot be sine y. Even if you expand sine y, you are going to get an infinite type of polynomial. But if you compare linear differential equation even with a polynomial, that is going to be a polynomial with finite number of terms. So even if you try to expand it, you are going to get infinite terms. So this is a non-linear differential equation. Anything which you cannot compare with above form is a non-linear differential equation. So non-linear differential equation is basically, I can read that out for you. It contains, if the dependent variables and its derivatives are of degree 1. So all the dependent variables like y is their dependent variable, and its derivatives all have power 1, all are raised to power 1, not more than that. And there shouldn't be any product of dependent or independent variables. Dependent variable and its derivatives. For example, if I write this equation, y into dy by dx is equals to 1, let's say. So here, even if you try to make it in the above form, you will get 1 over y. But that is not comparable with the other above form because y and its derivative was multiplied. So 1 by y can't be compared with above form. So this is a non-linear differential equation. Also, you can't have powers like this. For example, y square dy by dx plus x is equal to 0. This is also a non-linear differential equation. Why? Because y is raised to power 2. You can't have 2 power above y or above any derivative of y. So a general kind of differential equation which is linear would look something, something like this. It could be anything. So this is a linear differential equation because you have multiplied derivatives with the functions of x. Now this is a constant function and now this is a function. So if you want to multiply the derivatives or y with some function, that should be a function of x, and that's the identity of the linear differential equations. So now you might have a clear idea of what a differential linear or a non-linear differential equation look like. I will give you another example and will try to ask you if this is a differential equation. If someone can unmute and tell me if this is a linear or non-linear differential equation.
Linear.
Someone is saying linear, so 1 vote for linear. Yeah. Please. What you were saying?
Linear.
Linear. Everyone is saying linear. This is an absolute function of y. Keep in mind, okay? So everyone is saying linear, okay? If someone wants to give a different answer, they can. So I gave you the correct form of linear differential equation. It looks something like a polynomial. Why is it called linear? You might be wondering why is it called linear? Because all derivatives have power 1. If you raise it to powers greater than 1, they will be non-linear. Or it contains some non-linear function, it will be called non-linear. So in this case, every derivative or the dependent variable all have power 1, but mod y was a non-linear function. We have included a non-linear function in this, and that's why it becomes a non-linear differential equation. You should have a linear function, or even if you're not able to compare it with the original form, you will call it the non-linear differential equation because the original form doesn't contain any modulus function. And you can't separate mod y with like some function of x, let's say some function of x into y. You can't do it like this. So y is a non-linear function. When linear functions look something like a scalar multiple or something, mod y, it depends on if y is greater than or equal to 0, you will write plus y. And if it is less than or equal to 0, you will write minus y. So it depends on what sign y keep. So this is why it is called the non-linear function. So modulus function, absolute function is a non-linear function, and that's why this equation was non-linear. That was a good question. And you can also try out this question and ask me later at the end of this if this is linear or non-linear. I will tell you after we finish the lecture at the time of discussion. So let's move on to some interesting topic. Let's look at a question which came in some exam of yours. Maybe it was CSIR-NET. I don't remember the year. So this was a question. You might want to try it out. Let me help you. So we have been given a x, y, y dash. This is a function. X, y, y dash, y double dash. There are n derivatives of n. So this function includes n derivatives of n and x. So this means a function that includes a dependent variable and its derivatives, and also one independent variable is there, like x. So what does that mean? That means this function is nothing but a differential equation. They have written it. Let f of something is equal to 0 be the nth order differential equation. Because it is a differential equation, as it contains the independent variable, the derivatives of the dependent with respect to the independent, and they have also mentioned here that this is an nth order differential equation. Now they have asked us 4 questions. If degree of this, now what does that mean? Let me help you understand this particular statement. What does this mean? If degree of f equal to 0 equal to 1, what does that mean? It means if degree of this equation is equal to 1. If degree of this particular equation, what does this equation means? I have used 3 horizontal lines, f equal to 0. This means this was the original equation that was given. When you use 3 horizontal lines, it means f is identically equal to 0 because it was given, and that's why we use 3 horizontal lines. So whatever is in the bracket, that represents the differential equation, because equation is something that contains equal sign, obviously. So f equal to 0, we have been given f of something equal to 0. F of something equal to 0. This complete thing will be called the differential equation. So whatever is present in the bracket in the option first is differential equation. Equal to 1. If degree of this particular equation is equal to 1, then this is linear. Do you agree with this? I don't think I do. And let me read out all the options for you, then we'll cover it one by one. And then they say if f is 0, f equal to 0. That means the differential equation. This complete thing represents the differential equation. If the differential equation is linear, then degree is equal to 1. If the degree of the differential equation, third option, is greater than 1, then it is non-linear. And the fourth option says if the differential equation is non-linear, then degree is greater than 1. So all options seem to be, same. They represent different meanings, but they look like they are They look like they have been asking the same thing, but let us figure out what they have been asking. Let me discuss with you the first option. If degree of this equation is 1, then it is linear. Is it so? Let me write a differential equation for you. dy by dx is equal to sine y. Can somebody tell me, is it linear or non-linear? Fast.
Non-linear.
It is a non-linear differential equation. But option 1 says that if degree of some differential equation, this is a differential equation, it is equal to 1, the degree is equal to 1, then it is linear. No, I have taken a counter example which says that a non-linear differential equation can also have 1 degree because its order is 1 and its degree is also 1. You can see it. But this is a non-linear differential equation. You can't compare it with the linear differential equation form. So A option is incorrect. So A option is incorrect. Let me write here. B option says if f equal to 0, which means the differential equation is linear, then degree equal to 1. The differential equation is linear, then degree equal to 1. Yes. Don't we say that the linear differential equations have 1 degree? Because when we use the general form of a linear differential equation, we saw that, you can't raise powers of, you can't raise a power 2 or 3 or something like that. Just a minute. We knew that we can't raise their powers more than 1. So that means B option is correct, because in the definition itself, linear differential equation says that its degree is 1. And even if you didn't notice it there, you should notice it now, that linear differential equations have degree equal to 1. So this option will be correct option. Now let me tell you that this question is an multiple select type question, MSQ type questions. And these days, each and every exam has these multiple select type questions. So if you want to attempt these kind of questions, you need to be very careful. Okay. Now more than one option can be correct, and there's no partial marking. Even if you miss out one of the options, or you pick one extra option, you want to be given any marks, not even 0.1 mark for this. So you need to be very careful while doing these kind of questions. You need to read out each and every option very thoroughly and understand what they are trying to say. So that's why I spent extra 5 minutes in explaining to you what these options are saying. So I hope these are clear to you, option A and B. Now let us move on to option C. It says if degree is greater than 1, then F is non-linear. If degree of the equation is greater than 1, then it is clearly non-linear. Well, this is nothing but the B statement. Why am I saying this? Because you might have studied contrapositives. I don't know if you have. What are contrapositive? If a statement says that P implies Q, if P, then Q. If P, then Q. What is its contrapositive? If you are asked to find contrapositive.
Negation of Q implies negation of P.
Yes, exactly. Negation of Q implies negation of P. Very good. Yeah. So contrapositive says negation of Q implies negation of P. So what is the use of contrapositive? If, listen carefully, if a statement is true, for example, P implies Q was true, then its contrapositive is also true. You can note it down. Contrapositive is also true. But if the statement is false, then the contrapositive is also false. So whatever the statement's behavior is, the contrapositive behaves the same. And contrapositive plays a vital role while you are attempting questions in exams. So it is very important for your NET, GATE or JAM exams, or whatever competitive exams are you going to give, maybe NBHM or for exam. So keep in mind. Now, our statement was equation is linear. Let me write the B statement, B option statement. Equation is linear. Differential equation is linear implies degree equal to 1. I have written it in short. Now, P implies Q. What is contrapositive? What its contrapositive is? Not Q implies not P. What is not Q? What is the negation of Q? Degree not equal to 1 implies not P. What is the negation of P? Equation is not linear. So if degree is not equal to 1, equation is not linear. So this means if B option is correct, C option is also correct, because C option is the contrapositive of B, and vice versa, because a contrapositive of a contrapositive is the actual statement. Now if you again take the contrapositive of C, you will get the B option, because you will again apply negation over negation. So that is it. So B and C options are same. In my words, they're same because they are each other's contrapositive. So B and C are correct. Now, we didn't have to do extra, hard work for the C option, and that's very important while attempting the questions in exam. You can't. You should have to be, very smart while doing these kind of options. Now, D option says if the equation F identically equal to 0, which means if this means if this is the equation. If this is non-linear, then degree of this means the equation. If the equation is non-linear, then the degree of the equation is greater than 1. Do you agree with this?
No, ma'am.
No, ma'am.
Ma'am.
Exactly no. Because A option was this. If degree is equal to 1, then F is linear. Now, D option is a contrapositive of A option. And if A was incorrect, then D is also incorrect with the same kind of example. What was the example that we took? And you could take any kind of example, you know. You can take, for D option, let me write T option. You could take this example. This is a nonlinear differential equation, but its degree is equal to 1. So D option is incorrect. So you will only have to work for 2 options here, and you can attempt 4 options. And generally, these kind of multiple select questions weigh more marks than, you know, single correct questions. If single correct questions are 1 mark, they will carry 2 marks. Or maybe in CSIR-NET, they are of single correct are of 3 marks. Then the multiple correct are of 4.75 marks. So if you can attempt these questions very carefully, then you will surely get the benefit. Let me move on to another section. And let me see. Yeah, there's one more important result, or let me say theorem, that you need to cover before moving forward. Because after this topic, I'm going to cover the autonomous differential equation, because that is not something you will find everywhere. You will not find it on YouTube easily, and you'll not find it on many coaching centers. So I'll cover that topic of autonomous differential equations, which is covered in almost all of the exams. Say TIFR, say it, I don't know about NBHM, but it's in TIFR, CSIR-NET, GATE, and even IIT JAM. All of these exams cover these kind of questions. So we'll move on to that topic after we finish learning this theorem. So what does it say? Existence and uniqueness theorem. What does it say? If f of xy and del f over del y. What is del f over del y? Let's say you have a differential equation dy over dx is equals to f of xy. For example, you might be wondering what kind of differential equation is this? This is a first order, first degree differential equation. It can be linear or it can't be linear. Let me give you an example. It can be linear or non-linear. For example, if I write this equation dy by dx is equal to y squared, this is a non-linear kind of equation. And is it a function of x and y both? Of course it is.
Yeah.
Because exactly, of course it is, because you can write it as x raised to power 0. You know, x doesn't have to be there, you know, and you understand that. So this is a non-linear differential equation. Now let me write another differential equation dy by dx is equals to, let's say, x squared. So this is a linear differential equation. You know, so these kind of equations form first order, first degree, covers both linear and non-linear. So what does existence and uniqueness theorem says? It says if you have a function f of xy, which was this, I wrote this down, and the partial derivative del f over del y, you need to partially derivate this function with respect to y. If these both are continuous of x functions of x and y in the given region, whatever the given region is, or I will tell you how to figure out this kind of region. In the region D, whatever the region there will be, there's always a domain of a differential equation. I will tell you in the later section. There's always a domain of function. You know the domain of function. So there's also a domain of differential equation in which the differential equation is defined. So the region D denotes that kind of domain of differential equation. Region D of the xy plane. Why the region D is in xy plane? Because the domain of the differential equation, I mean, it is denoted with the help of, you know, your differential equation gives solution in this kind of region. So the region that is there is a subset of xy plane. So D is a subset of R square. You know, it is in the xy plane. So they are written in a region D of xy plane. And if the point P, x naught, y naught. Now, what is x naught, y naught? The x naught, y naught is a given condition. For example, now you will be dealing with differential equations with given conditions. initial conditions, boundary conditions. I will explain it to you with the help of an example, but let me first read out this statement. And if this point belongs to D, then there exists some neighborhood of P contained in D is the solution of, then there exists one and only one function, say phi of x, which is in some neighborhood of P and contained in D and is the solution of the differential equation. So in short, what does this statement mean? If you have a differential equation like this, and you know there is some given condition, phi x naught is equals to y naught at x naught point, or it could be, you know, y x naught is equals to y x naught is equals to, let's say, y naught. So the given point P will be x naught y naught. For example, if your differential equation is dy by dx is equals to y, and the initial condition is y naught is equals to 1. Now you are asked to find the solution of this differential equation. Now there is a very basic way of finding the solution of this differential equation, which is called the variable separable form. You know, there's a lot more to cover in the basics of differential equation, but not everything can be covered in just a 2-hour lecture. I'll try my best to explain it to you. Variable separable form. You already know this variable separable form. What you do is you take one variable on one side and another variable on another side, and then you integrate it. We have studied this even in our 12th standard and maybe first or second year of our bachelor's degree. And if you are in the first year of your bachelor's degree, you still know it because you've done it in your school time. So now we integrate it, we get log y is equals to x plus some constant, because when you are integrating indefinite integration you are doing, you will always get a, you know, arbitrary constant. So if you want to write y in terms of x, you will write y is equals to e I was again muted, I'm sorry. So yeah, now they have given us y0 is equals to 1 as the condition. Let me apply that. That's very easy. Y0 is equals to 1 was the condition. Now when you put x is equals to 0, you should get y is equals to 1. So let me put y is equals to 1 and x is equals to 0. So to get e to the c equals to 1. Well, at what c will e to the c will be equal to 1? This exponential function is equals to 1 at
0.
C is equals to 0. Exactly. So the main motive of doing all of this calculation later on was to find the arbitrary constant, which is in this case is 0. So our solution looks like something like this: e to the x plus c. C was 0. So x plus 0. So this means this is the final solution. So that is how you solve this kind of differential equation, and that is, you know, that was given. Now you could also, without even solving, now after solving, what you find that you have this solution, which is a unique solution. You know, after solving, we found out that this is a differential equation with this condition and it has a unique solution. But if you were not to solve this equation, how would you find out that this differential equation has a unique solution? Let me tell you. In this case, f of xy, with the theorem, in this case, f of xy was equal to y. And there was this given condition, y0 equals to 1. Now, this is in the neighborhood of, now we need to see the neighborhood of this point. To find the region D, we were supposed to find the D region, which I told you that was a subset of R square. So f of xy and del f over del y, which is in this case 1, they should both be continuous functions in the given region D. So if no region is given, we take the neighborhood of this point. What is the point? 0, 1. whichever point is given in the initial condition, it is 0, 1 here. X coordinate is 0, y coordinate is 1. So 0, 1 point is this, and you take maybe a square neighborhood of or a circular neighborhood of this, and you just see that neighborhood means it could be very small, very small, very small, you know. So you need to keep that in mind. Now, if del f over del y, it is always a continuous function. If this is continuous and this is also continuous, is it continuous? Yes, of course it is continuous because this is a function known as y. How to figure out if it is continuous around 0, 1 point? It is continuous because it is defined everywhere and it is a polynomial kind of function. You will figure out many ways to find out continuous functions in function of several variables, 2-variable calculus. But for now, you can easily just look at it and find out that this is a very no problem creating kind of function. And another one, del f over del y is 1, so this is also continuous. So we don't have any problem. So this means that all the conditions of the given theorem is satisfied. So Picard's existence and uniqueness theorem says if this, all of these things hold, that f is continuous, del f over del y is continuous, and this kind of differential equation is also given to you. So this means that you don't have to solve it for knowing whether it contains a unique solution or not. This theorem says that if these conditions are satisfied of continuity, then this system, this differential equation plus this initial condition, this will have a unique solution. Now, same thing holds here. I had this differential equation, which I took as an example. I solved it. I found this is as a unique solution. But if someone asks you, by giving this differential equation, to find out whether it has a unique solution or not, what will you do? You can look out for this kind of solution. But this is just a sufficient condition. There is a drawback of this theorem that this is just a sufficient condition, not a necessary condition. For example, I will give you an example. If you are clear up to this point, I will give you another example showing that for any differential equation, these conditions might not hold, but it can still have a unique solution, or maybe solution could exist. Yeah. Okay, let me cover that later because that example is going to take a bit of time. So let me cover that after I'm done with my autonomous section for this lecture. But what I'm telling you that this condition is sufficient, but it is not necessary for having a differential equation a unique solution. So you need to keep that in mind. Now I will move on to the another section, and yeah, we can move on to another section. But before that, yes, now comes the very important and the very interesting part of this lecture. And also, before that, let me give you a little idea of general solution and particular solution. What is a general solution for a differential equation and what is a particular solution of a differential equation? Well, when we study differential equation, we know one thing, that for a differential equation, for any n order or whatever differential equation we have, let's say we have an n order differential equation, and which contains nth order derivatives. For example, let me take n is equal to 2. And if you have a differential equation like this, then you must have its solution, right? Its solution must be there. And this solution will be called the general solution. As I know how to solve this kind of differential equation, I'll directly write its solution. So don't worry about how did I solve it. You will also get this idea in the later lectures of ODE that you are going to attend. So the solution of this kind of ODE looks something like this: C1 cos x plus C2 sin x. I already knew, that's why I wrote this. Now, this differential equation has two arbitrary constants, and the order of the derivative of this differential equation was also 2. So when you solve an order differential equation, the solution that you get contains an arbitrary constant. For example, here it was 2 order, and you got 2 arbitrary constants. So if conditions are given according to that, for example, if there is 2 order differential equation, you might get some equation like this. For example, one condition was given: YA is equals to B. YA1 is equals to B1. If you apply this condition on your solution, what you will get in result is one arbitrary constant. So if you apply one condition, one arbitrary constant will be removed. And let's say there was these 2 conditions that were given. If you apply 2 conditions on a 2-order differential equation, then what will happen? All the arbitrary constants will be gone. Let me give you an example. Let me write some really cool. Okay. Y pi by 2 is equals to 1. That's it. Okay. Now let us apply these conditions on our y. Let's do it. So if I put x is equals to 0, I should get y is equals to 0. So if I put x is equals to 0, what will happen? C1 cos 0. Cos 0 means 1. Plus C2 sin 0. Sin 0 means 0. So what you will get is y is equal to C1. Sorry, y is equals to C1. 0. Y was 0. 0 is equals to C1. So this means that C1 becomes 0. Now, if you want to apply the second condition, what will happen? Now your equation is C1 cos x plus C2 sin x, but C1 has become 0. So what will I do? I will put 0 here. So my solution becomes C2 sin x. Now try and apply this condition on this. So what will happen? Y is equals to 1 is equals to C2 sin x, means x is pi by 2. So 1 is equals to C2 into sin pi by 2 is 1. So this means what happened? C2 became 1. So this means all in all your solution will be y is equals to 1 into sin x. So this means the solution becomes y is equals to sin x. Now the solution that you obtained now is a particular solution. Now this won't be called a general solution. After applying the conditions, whatever the initial conditions are, after applying these conditions, when you get this kind of solution, which contains no arbitrary constant, it is called a particular solution. Or I can say, when you got this general solution, C1 cos x plus C2 sin x, if you put C1, C2 are any arbitrary constant, they can be any real number, or sometimes they can also be complex numbers. But if I put C1 is equals to 1 and C2 is equals to 1, that's up to me, whatever I want to put, because they are arbitrary. So in this case, I would have got, let's say, if only this equation was given, and if I give these arbitrary constants some specific value, like 1 and 1, so my solution would have been cos x plus sin x. This is also called a particular solution. So there are 2 ways of finding a particular solution. One is whatever the order of the differential equation should be the number of conditions that should be given. So if it is an n-order differential equation, n conditions should be given so that we can find a final unique kind of solution, right? this solution wasn't unique. General solution is not unique because it contains arbitrary constants, and this contains infinitely many solutions that satisfies above equation. You can put any of these solutions, either this general solution, or this particular solution, or this solution which we got, this particular solution. You can put it here, and you will notice that all of these three solutions satisfy this differential equation, because all of these are solutions of this differential equation. So in other words, what I can say is that this is a general solution. It is a family of curves, because without a family of curves, you can't have a differential equation. For example, let me give you a brief idea about this. If you have y is equals to x, this is a straight line according to you. And I have taken y is equals to ax, right? This is a family of straight lines according to me, right? Straight lines passing through origin, right? These are the family of straight lines passing through origin, because a could be anything. A was belong to R, right? A could be 0, a could be non-zero, a could be anything. Family of straight lines. Now, can I make differential equation from both of this? What do I need to do to make a differential equation from both of these? I need to derivate it. So when you derivate it, dy by dx is equals to 1. You get this. And when you derivate this, what you get is dy by dx is equals to a. Right? Now, while making the differential equation, you need to remove this arbitrary constant. So how will you remove this arbitrary constant? From equation 1, you need to find the value of a and then substitute it here. So I will get dy by dx is equals to y over x. When you do that, you get the right differential equation. This wasn't a differential equation because it contained arbitrary constant. And I have told you, it can contain fixed constants, but it cannot contain arbitrary constant, because a differential equation contains only three things: the dependent variables, the independent variables, and the derivative of dependent with respect to the independent. Are you getting my point?
Yes, ma'am.
Now let's talk about this one. Is it a differential equation? I took one straight line and I made this equation. Is it a differential equation? Well, let's figure it out and let's try and dive deep into it. You will tell me by yourself if this is a differential equation or not. If this is a differential equation, let us suppose this is a differential equation. So what will happen? You can write it as like this. Okay. Now, to find the original solution, reaching out to the original solution, what would be the method that I'll use? I will use the method of indefinite integration, means variable separable method, which is the easiest way to solve any differential equation. So this becomes y is equals to x plus c. So this is your solution. This should be a solution, but there's a problem. This isn't the solution. This should have taken you to where you started, but this has not, because it came out to be a family. Let's say, let me take some another constant. Yeah, c is good. C is good. Okay. So this has given you the family of straight lines, the family, but the original where we started was a single straight line. So there's a contradiction in both of these, because where you started, you should have finished at that same point. Because if you want to do the same thing here, you can do it. Dy over y is equals to dx over x, and then when you will apply variable separable form, you will get, let me solve it for you. Log y is equals to log x plus log a, let's say some a or c, it could be anything. And then you will get log y is equals to log ax. And then you would have got y is equals to ax, right? So it took you to the original family, but it couldn't, because that is always going to give you a family. Whenever you solve a differential equation, You always get a family. You always get a general solution. General solution or family are same. Family of curves or general solution. But you started with a single straight line. So what we figured out from this problem is that you can't take a single curve and make a differential equation out of it, because that will create a contradiction like this. So we will always need a family of curves while making a differential equation. And whenever you solve a differential equation, you will always get a family of curves in result. Except the fact whenever there is this condition, let's say, whenever there is conditions like x naught is equals to y naught, or maybe some other conditions are given, that is going to convert in a specific kind of curve, and it's going to remove the arbitrary constant. But until and unless you just have a differential equation, you always need, you always are going to get the solution in the form of a family of curves. So you can't have a single curve and make a differential equation out of it. We have seen it on the left side. And if you have a family of curves, you can surely make a differential equation out of it. Another thing that we noticed was, if you have a differential equation, then you will have to, when you find the solution of this differential equation, you will always get a general solution or a family of curves, until and unless you apply the specific conditions that are given. And in that case, you will get some particular solution. So family, for making a differential equation, you need a family, or for solving a differential equation, after you solve it, you get a family. So family and equation and family, both are interconnected. So now you might have a clear idea.
Ma'am,
Yeah, please ask.
I have a doubt. You said that solution of any differential equation is represented family of curves. So is there any region that the curve can be drawn, or the whole plane or whole domain of the differential equation?
Curve can be drawn on? I couldn't understand.
My question is is there any domain for the curves, or I mean, how can you get the domain of the curves?
To get the domain of the curves, it's so easy. See, whatever the curve is, y is equals to ax. How do you draw these family of curves? For example, you have this family of curves. Sometimes you have this parabola kind of thing. Y is equals to x plus c to the whole square. So how do you draw these family of curves? You take every line passing from the origin. At the end of the day, it is going to cover actually the whole plane. But to see them, we just draw these finite number of lines. But it is obviously, we know that it is going to cover the whole plane when you have a line at every point. So for drawing these curves, whatever specific criteria you need is there. For example, you need to, if you want to draw this parabola, how will you draw it? X plus c. X is equals to minus c. Y is equals to x. Yeah, this will be an upward parabola, like this, like this, like this. It depends on what the center and focus would be. So these parabolas will be like this. Whenever you draw them, they will be infinite in number, and at the after some time, they will cover the whole plane. But to see them, they're like a family. So what I mean is, you can easily see the domain of these curves specifically, because you can draw these lines and draw these parabolas. There's no problem. They have the whole real line as their domain. There is no problem in drawing them.
I mean, seeing the questions itself, can I get the domain? I mean,
okay.
Only if I given the differential equation, or if we get the
yes, for example, this is a differential equation 1 over y. Right. If this differential equation is given and someone asks you find the domain of this differential equation. So first you find the domain of this differential equation, which should be y should not be equal to 0. Whatever the solution is. For example, if you find the solution, what would be the solution? Y dy is equals to dx. What would be the solution? Y square by 2 is equals to x. So that means y is equals to 2x plus c, and that will be square rooted. Y should not be equal to 0, they have said. So that might not be the restriction on the original curve, but that is the restriction on the differential equation. Well, let me tell you, the domain of differential equation is different than the domain of its curves. So it is a different thing. Whenever you are finding the domain of a differential equation, it is a different thing. And the domain of its solution, it is a different thing. So whenever you find the domain, you will say that y is non-zero. So the only difference that it will make, you can't draw this curve, you can't take y is equal to 0 in your solution curve. That's the only difference. But what I mean is, you can have different domains for both of your curves and the differential equation. That is completely normal. So you don't need to worry about that they should be same or something like that. It depends on the solution because they have different domains. That's what I mean. Okay?
Okay, ma'am, I got it.
Yeah. So let us move on to the very interesting topic, which is autonomous differential equation. And there's a lot more to cover, but yeah, hopefully if I take next lecture, I will cover those topics, but very important topic is autonomous differential equations. So let me write autonomous differential equations. So these are some special type of differential equations. These are differential equations of this form. These are first order, first degree differential equations. They need not be linear, not at all, because I can give you another two examples like dy by dx is equal to y, or dy by dx is equals to y square. Both are different. One is linear and another is non-linear. So linear and non-linear is not a fact here. So these kind of equations where dy by dx is equal to some function of y, only y should be there, only function of y. These kind of differential equations have a specific way of solving. And why are we solving this? Why do we even need to solve these kind of equations? Because they are very important for the exam. And you can just draw simple graphs to know the behavior of the solutions. Because see, no one is going to ask you find the solution. Never ever you will find this question in any of your competitive exams, because we are studying for competitive exams. Never ever you will find this question, find the solution. They never ask you directly. For example, dy by dx is equals to y into y minus 1 into y minus 2 into y minus 3. You can do it with variable separable form. I know that. Most of the students will do it with variable separable form, but we are not. Because we are not supposed to find the solution of this differential equation. They have asked the solution, behavior of the solution, how solution behaves. So you also need to shift your mindset from this, which is not asked in the exams, none of your exams, to this. Okay, this is the correct way of thinking about the question and solving for. Okay, so they haven't asked the solution, so we won't find the solution. They have asked the behavior of the solution, so yes, we'll find the behavior of the solution. And for finding the behavior of the solution, autonomous differential equation helps us really well. So let us move on and see what an autonomous differential equation is. So whenever you have a differential equation like this, let's say you have a differential equation like this, just this. Is it autonomous? You will say yes, because this is a function of only y. How do you find the solution of this differential equation? Well, the easiest way to find the solution of this differential equation, well, you might notice that I asked you not to find the solution, but to find the behavior. But now I'm finding the solution of this equation. Yes. Sometimes you can find the equation. You don't have to be very rigid about it. So I'm giving you an idea. Later on, as we increase the difficulty level of the questions, we won't need to find the solutions of the differential equation. So one kind of solution is what we usually do, variable separable form. and I did that earlier for you to solve this kind of equation. And we solved it and we got y is equals to e to the x plus c, something like that. I don't exactly remember. Yeah, it was this. Or you could also write it as e to the x into e to the c, which you could write like k into e to the x, because I have written e to the c as k. Okay, right. So I have just modified a little bit the constant. Okay, nothing else. You could write the solution also like this. Now, another way I can find its solution is, let me tell you, put fy is equals to 0. Okay, put fy is equals to 0. Here fy is y. So y is equals to 0. So when y is equals to 0, does it even satisfy the original equation? Can somebody tell me, does it even satisfy y is equal to 0? Satisfies the differential equation or not? What do you think? It does satisfy or not? This
No.
is our original. No.
If k not equal to 0.
With k not equal to, don't look at that. Okay, I'm just asking, does the solution satisfy the equation? That is one way of finding the solution. That is my another solution. Okay, I'm asking, does this solution satisfy? I know that upper solution satisfies it. E to the power x satisfies it. I know that. But does this satisfy the equation? Let me just try and put it out. You know, when y is equals to 0, its derivative is also equal to 0. So dy by dx will also be equal to 0. And y is itself 0. So 0 equals to 0. It satisfies the equation. So that means that y is equal to 0 is also a solution of this equation. That is the thing. So y is equal to 0 is a solution. And you can also find this solution with the help of that particular upper solution, where if you put k was an arbitrary constant, if you put k equal to 0, what you will get? You will get y is equals to 0. So you could also get this particular solution from above solution, but in this way you are only getting one solution, right? Now let me tell you one more interesting thing. Now you might be wondering, what's in this? This is crazy. I mean, I'm just asking you to find one solution. When you have, these infinite kind of solutions, why will you find one solution only? Okay, let me tell you. Why is this useful and why should you do this? Suppose we have the same differential equation with given condition y0 equal to 0. What will we do now? Now I could also find its solution in two ways. One was y equal to 0, as you saw, and one was y is equals to k into e to the x, right? Now, when I said that if you have an nth order differential equation, nth order linear differential equation, yeah, was it linear? Let me confirm. Yeah, it was any nth order differential equation. If we have any nth order differential equation, then plus if we have n conditions, n initial conditions on that equation. For example, here it is a one order differential equation and we have one condition. Then what we get is a unique solution. In that case, that solution will be called particular solution. Unique solution in that case we get, right? So you know that it is going to be a unique solution. So what do you think? Do you want to still solve it or go for this? Because I do want to verify that y is equals to 1 satisfies it or not. Let me verify it, okay? It satisfies the equation we have seen earlier, but does it satisfy the condition? Now you are saying that yx is equals to 0 because y is identically 0, so yx is 0 for all x. So this means y will be 0 on 0. That's so easy. If it is 0 on all points, on 0, on x is equal to 0, it will also be equal to 0. So that means it satisfies both the equation and the condition. So this will be a solution. This will be a solution. But this is kind of like a guesswork, right? You might say that this is kind of a guesswork thing that I did. And this will help you in exams, by the way. But you might not be satisfied with this kind of guesswork. So let me solve it for you and show you that y is equal to 0 is the only solution for this equation, this system. Okay. So this was our general solution. General solution. So y0 equal to 0. We have to put y0 and we have to put x also equal to 0. So what will I get? K into 1. So what will I get? K is equal to 0. So this means that y is equal to 0 into e to the x is the new solution for me after putting the condition. So also this kind of lengthy work also gives me y is equal to 0 is the solution for this equation. And this way I guessed it like this. How I am finding these kind of solutions is because of the fact that this is an autonomous differential equation. Are you all clear up to now? If you have any little doubt, you can clear it here because we are going to dive deep into the topic because this was a very basic thing. Okay, I suppose you all are clear. So let me take this kind of differential equation. What will happen now? Now you know that this will be having a unique solution. If it has a solution, it will be unique. If it has a solution, then it will be unique. Also, it will have a solution by uniqueness and existence theorem that I told you, because this is continuous and its partial derivative, which will be 2y minus 1, something like that, will also be continuous. So it will have a unique solution. But if it did, even if you don't know about the uniqueness and existence theorem, it doesn't matter because you know that if the solution exists, it will be unique. Now the question arises, what is its solution? Now, traditionally, what you will do, you will be a sincere kid, and what you will do, you will try to do it with this method, which is called the variable separable method, right? And then you will apply the condition and find out the unique solution, whichever it exists. But now you will have to do the partial, what is it called? Partial fraction. Now you will have to do partial fraction, then apply the condition, and it will be a long, long work. And we can't afford to do it if the question is changed to y minus 2. These three factors, you can't afford to do it in exams. You will waste your at least 10 minutes. So we won't follow this kind of practice. We will follow a new practice. Okay, what is that new practice? Let me tell you. I can guess that its three solutions will be by putting f of y is equal to 0. Its three solutions will be y is equal to 0, y is equals to 1, y is equals to 2. Equilibrium solutions. Do you have an idea about equilibrium solutions? You might not, because when you put fy is equals to 0, what you get is equilibrium solutions. These solutions are called equilibrium solutions. But that's not the end of this question, because they have also given this condition to us. Y0 is equals to 1. Since y is equal to 0 is always equal to 0, it is never equal to 1. So this will not satisfy our condition. So I will reject it. Y is equals to 1 satisfies this condition because it is always equal to 1. So at 0, it will also be equal to 1. Y is equal to 2 also doesn't satisfy this because it is identically always equal to 2, is a constant. So can it be equal to 1 at 0? No, not at all. So this will also be cancelled. This also can't be the solution of this particular initial value problem. This condition is called initial condition. Always remember. So now I am left with only one solution, that is y is equals to 1. Will it be the solution? It will be the solution, and I can prove it to you. How can I prove it to you? Until then, you were not satisfied that y equal to 1 is the solution, but now I can prove it to you with the help of uniqueness and existence theorem. That theorem says when you have an n order, when you have a differential equation like this, first order, first degree, and you have, this f of y or f of xy, and its partial derivative both to be continuous, which they are around this point, whatever this point is, 0, 1. Its derivative will also be a polynomial kind of function. It is also a polynomial kind of function. Both are continuous. So uniqueness and existence theorem says that it will have a unique solution. And I have found out one solution by myself. One solution. This is one solution. Yes. And I'm saying by uniqueness and existence theorem that the solution should be unique. So this means that this will be the only solution. And if you don't believe me, please do not try after this class, try and do it with the help of partial fraction. Even if you remove this y minus 2 in the fraction, you can try it with the partial fraction thing. You will find the same solution. I can guarantee. Okay? But there's still a problem. If someone wants to ask anything, there's still a problem.
Ma'am,
Are you?
suppose,
Yeah. Yeah.
suppose the initial condition may be changed then?
Yes, exactly. That's what I was going to cover now. Initial condition is not always going to be in your favor, like y equal to 1 or y equal to 0, something like this. Initial condition might be something like this. Sorry, 1 by 2. Now what will you do? Now you will start this question by finding the equilibrium solution. This is an autonomous differential equation. So for autonomous, what we find is equilibrium solution. Now you will start the question in the same manner, but you will be stuck after doing this. Y is equal to 0 or y is equal to 1. You don't want to go in the long method of doing the partial fraction things and all that. You still want to stay at the shortcut method, which is a very good method. Now what will you do? You can't find the exact solution, I can say, but they also won't ask you the exact solution. That's the whole thing. That's the whole story here. They won't find you. For example, if they give you this question, their options in exams will be limit x approaching to infinity, yx is equals to 1. Limit x approaching to infinity, yx is equals to 0. Limit x approaching to yx infinity, or maybe, third option could be like something different. It could be saying yx is bounded, something like that. These are the properties of the function. Yx is monotone and blah, blah, blah. Okay, I can maybe add some another option. I will also help you solve different GATE and NET exam questions related to this. But just first, let me clear everything about this particular topic. And I will also be sharing the notes in which you will find, 5 to 10 questions related to this topic only, which will be a great way to practice. So y is equal to 0 is not a solution clearly because it doesn't satisfy the initial condition. It satisfies the differential equation for sure, but it doesn't satisfy the condition. It also doesn't satisfy the condition. What should we do now? Because we're not able to find the solution now. Okay. We are not asked to find the solution first of all, so we will not find the solution, but we will use a method that will tell us how the solution behaves. Let me put when x is 0, y is 1 by 2. So this means now change your perspective about things. Now, try to see things graphically. Y0 is equal to 1 by 2. Means that when x is equal to 0, y is 1 by 2. Means something if y is 1, 2, 3. Let's say 1, 2, 3 is here, 0 is here. So when x is 0, y is 1 by 2. So this is a point with which our solution passes. This is the first thing that you need to do. That y0 is equals to 1 by 2. This is the first thing that we did. Now, second thing what we need to do is on this graph, all your question will be solved on this graph itself. And graph is so easy, you won't even think about doing anything other than this once you learn this method technique. dy by dx is equal to y to y minus 1. Okay. What is this? What is dy by dx? dy by dx is slope. Now try to see it as a slope thing, because you have jumped into graphs. Okay, this is a slope. First of all, what I will do is y into y minus 1. I will put f of y is equal to 0, means y into y minus 1 is equal to 0. I will get two kind of solutions. I asked you, these are not the solutions, but these are equilibrium solutions. Even if they are not the solution of this system, but they are called equilibrium solutions. How will they help us? Let me tell you. You need to draw horizontal lines. I mean, y is equal to 0 is something you need to draw. Y is equal to 1 is something you need to draw. So y is equals to 1. I have drawn this line. Okay. Why am I doing this? You will get the idea in a very short span of time. Okay. I have drawn these two lines, y is equal to 0 and y is equal to 1. I have plotted the point half. Okay. Now, what is the slope's behavior? I mean, what if my y lies from, my solution lies from, let's say, 0 to 1 by 2, and then 1 by 2 to 1. What I'm asking you is to do this. Whenever y is from 0 to half, what does that mean? What does that mean? Whenever vertically y is from 0 to half, I mean, in this portion, how does it behave? How does my solution behave? I want to know the behavior of my solution. I will let you know that shortly. Let me just...
Solution is decreasing.
Yes. So dy by dx is positive or negative. That's the only thing that we need to see. Whenever it is less than y by 1 by 2, this will be positive and this will be negative. So overall, this will be negative. So the sign will be less than 0. And whenever y is from 1 by 2 to 1, it will still be negative, right? Because it will be positive and it will be negative. It will still be negative. It will still be less than 0. But you will need to make cases. We will see this in detail in further questions while we need to make cases. So dy by dx is decreasing. Matlab means y is a monotonically decreasing function from 0 to 1. And what about y is equal to 0 and y is equal to 1? When y is equal to 0 and y equal to 1, how does that solution behave? Let me tell you one thing. Because our solution does not pass through y is equal to 0 or y is equal to 1, because it passes through this point. And we have seen that y is equal to 0 and y is equal to 1 are not the points satisfied by our solution. Means that our solution does not touch y is equal to 1 and y is equal to 0. Okay. And our solution is decreasing. So our solution will be something like this. I have been making these arrows to get you an idea. These arrows are called slope fields. These are called slope fields. You will get the theory in detail in my notes. This graph is decreasing now. In this particular region from 0 to 1, our graph is, the solution is decreasing. And does it touch at y equal to 1 or y equal to 0? No, not at all. It doesn't touch these points because it doesn't pass through them. First of all, that idea is given with the help of this. So y equal to 1 and y is equal to 0 both act as asymptotes for our solution. Both act as asymptotes for our solution. You might have heard of this word, that once a curve passes parallelly through some line and does not touch it, that particular straight line is called the asymptote for that curve. So this will be the kind of, I don't know what the solution curve looks like, but I know one thing, that my solution curves passes through 0, 1 by 2, and it strictly decreases because the dy by dx sign is strictly less than 0 between 0 and 1. That is something I'm clear. Now, if I look at the options, what will be the options that will be correct? First option says that at x approaches to infinity, yx approaches to 1. Is it true? Well, I don't think so, because as x approaches to minus infinity, my solution is approaching to, it's near to, it's acting, y equal to 1 is acting like an asymptote. Y is equal to 1 is acting like asymptote as x approaches to minus infinity for this curve. And as x approaches to infinity, infinity is this side, right hand side, the curve is approaching to y equal to 0 but not passing through. It is approaching to, it is parallel to y equal to 0. So y equal to 0 now acts as an asymptote. So as x approaches to minus infinity, I can draw two conclusions here. Limit x approaching to minus infinity, y of x is equal to, as x approaches minus infinity, this is equal to 1. So the limiting value, it doesn't actually cut the point, but it approaches to 1. The solution approaches to 1. And on the infinity side, it approaches to 0. So what will be the correct option? First option says that x approaches to infinity, it goes to 1. No, not at all. As x approaches to minus infinity, it goes to 1. So first option is incorrect. Second option is correct, because we have noticed it right here. So second option is correct. Third option says your solution is bounded. Now, the thing is that the question doesn't end here. Let me tell you why. Because I haven't talked about 1 to infinity. What happens to my solution from when y belongs to 1 to infinity? What happens to my solution? When y belongs to minus infinity to 0, what happens to my solution? In this region and in this region, I haven't talked about the solution. So let us do that. So let us find the sign of the slope again, dy by dx, when y lies from 1 to infinity, and dy by dx when y lies from minus infinity to 1. What happens? So in 1 to infinity, everything is greater than 1. This is positive, so it becomes a positive thing. And whenever minus infinity to 0, I'm sorry. In this case, this is negative, both are negative, so dy by dx becomes a greater than 0. So both cases, dy by dx becomes positive. So solution is increasing, strictly increasing in this case. So we will start from minus infinity. We'll start from the left. We'll start drawing the arrows, and we'll take it to positive infinity. I don't have an idea about the graph, but I do have an idea that my solution approaches to infinity as x approaches to infinity. Again, here, the downward side, my solution also increases. And it goes to 0. It stops at 0. Why? You know why? Because equilibrium solution stops the solution. Any solution cannot cross the equilibrium solution until and unless that particular equilibrium solution is itself the solution. For example, in earlier cases, I was saying that dy by dx is equals to y into y minus 1, but the given conditions was on equilibrium solution. Now, if the given condition is on the point that is other than equilibrium solution point, that is 0 and 1, here it is 1 by 2. The condition is given at 1 by 2. But if the condition is not given at the equilibrium point solution, for example, 0 and 1, so our solution will never ever cross this y is equal to 0 line. That means the equilibrium solution will not be crossed. That's why here this solution is divided into 3 different sections. Okay. And also, I will have to do one more thing. Please ask.
Ma'am, maybe this for this differential equation solution is bounded, because we have to concentrate on initial condition also, right? Those solutions satisfy that initial condition. We have to say about bounded or not that solution, right?
those solution that satisfy the initial condition. Exactly. Yes, I was telling you, I just lost this point. Yes, exactly. So those solutions which satisfy the initial condition. What are those solutions? These are only the red arrows. These only lie from 0 to 1. Exactly. You're correct. And above solution, white solution, and the lower solution, which is in from -infinity to 0. These are the solution. These are the solution of the equation, not the equation and the initial conditions. So the only solution that we are concerned about in this question is lies from 0 to 1, and y lies from 0 to 1. So these are red arrows. So these are the behavior of the solution that we are concerned about. So they have asked you, are the solution bounded? C option was, if yx is bounded. You won't have to do this calculation. That depends on the question. I just forgot about it. Thank you for clearing. Thank you so much. Because we need to see now what point is the solutions that are passing through this point are the only solutions, because we need to consider this equation and the initial condition while we are solving for some differential equation. So these are the only solution to our differential equation because they pass through this particular point 0, 1/2 and they satisfy the equation also. So according to this, B option will be correct. B option can be asked like this or like this. That is completely okay. C option is yx is bounded. Of course it is bounded. Bounded between 0 and 1. Okay. So C is correct. Now D option was yx is monotone or not. If it says yx is strictly increasing, what should be your answer? D option is correct or not?
False.
It will be false, obviously. If it was strictly decreasing or like monotone, it would be correct.
Thank you, Unnati, for today's session. I'm sure that people really enjoyed this session on ordinary differential equation. Now it is a time for interaction. So, dear participants, you can ask your doubts or you can share your comments about the class. And also you can ask, as you know, Unnati has cleared almost all the competitive exams with good ranks. So you can ask her some tips for preparation. That also you can.
Thank you, Dayanand. You guys can ask anything related to the lecture or any tips that you want.
I just wanted to ask a question.
Yes, please.
Prabhat, could you introduce you?
Yes, ma'am. Myself, Prabhat Kumar from Bokaro, Jharkhand, and I'm studying BSc Mathematics, second year student.
Okay.
I just wanted to know that for clearing IIT JAM, we should be more focused on proofs of theorems or should be focused on problem solving?
If you want the answer in short, I will say that you should focus on problem solving first. And the idea about proofs is that you should see logics in the proofs, not each line proof you need to do. For any competitive exam, you just need to know the logic behind that proof. So you can, if you see a one-page solution in any book, what you can do is you can convert it into a half-page solution related to your logic. And one more thing is there. Please don't get me wrong. You don't need to do each and every solution. Like in this session, we hardly done any proof. Okay, yes. So competitive exams are a little bit different from reading proofs and writing your semester exams. It's a little bit different. So you need to focus more on problem solving. And if you want to do some proofs of some important theorems, you can just look at the proofs and try to find the logic behind them. That's what I can recommend you. So focus more on problem solving. That's the take you.
Thank you, ma'am.
Yeah.
Yeah, thank you, Prabhat. You should have a good conceptual level understanding of the subject and also should have a good practice of problems. Then only you can get good ranks in competitive exams. Okay,
Yes.
others.
एक्सक्यूज मी, मैं धर्मेंद्र
Yes,
BARC विशाखापट्टनम लाइब्रेरी से। मैं ये पूछना चाहता हूँ कि जैसे CMI ISI के जो एग्जाम होते हैं उनका कंसेप्ट काफी डीप लेवल होता है और IIT JAM इसका थोड़ा अलग होता है और टिफर में भी थोड़ा हाई लेवल होता है। तो इन दोनों तरह की तैयारी जो है उसको कैसे कंबाइंड लेके चलें साथ में?
See, I should answer in Hindi or English?
Both.
It's better to ask in, you can reply in English.
Okay,
That
sir.
will be more better.
Okay. See, what you can do is you can start your preparation with the easier exam. So I believe that IIT JAM is the easiest exam for mathematics. And then there's, GATE and then CSIR NET and NBHM. So you can increase your level, but you can start your preparation with the easiest exam. Suppose you are an MSc pass out, you won't prepare for IIT JAM. But what you can do is start solving the previous years of IIT JAM or any other MSc entrance exams that relates to, maybe you're preparing for CMI, let's say. So if that syllabus relates to your CMI syllabus, then you can solve the IIT JAM previous years first. Only those questions which are related to the previous year. Don't waste time in solving those questions which are not related to your syllabus, first of all. So try solving easy questions first and then come to more conceptual questions which are asked in CMI or NBHM or TIFR. And for that, you will also need to take help from books a little bit more than you take in your IIT JAM or CSIR NET exam. Students usually don't take much help for these exams from books, but maybe for CMI or not for TIFR, but CMI or NBHM exam, you need to take a little bit help from books and make your concepts really clear from. Even if you're not able to make it clear from books, you can take help from lectures and then you can keep on solving questions. That should be in your daily routine to solve at least 15 to 20 or maybe 50 questions to know how much you're preparing. So never ever do any shortage in solving questions. You can keep on solving questions and your doubts side by side, but also try to solve at least 10, 15, 20 or 50 questions daily to help you know yourself better. Testing yourself is very important in this scenario. So yes, that's my answer. Start with easy, go to difficult.
Okay, thank you, ma'am.
Yes, others.
Ma'am, good afternoon.
Good afternoon.
I'm Nandakumar from Tamil Nadu, ma'am.
Okay.
I have two questions, ma'am.
Yes,
Ma'am,
please.
I have prepared for CSIR NET exam, the coming NET exam. Ma'am, it is sufficient to see the previous year problems, or we should take the syllabus, entire syllabus by study the books, ma'am?
No, the most important thing while preparing for competitive exams is to know what exam are you preparing for. Suppose you are preparing for CSIR NET. So see, first of all, know the syllabus, and then you read the syllabus, you did the syllabus, and then when you complete a topic, let's say you completed sequence, then start solving questions for sequence from previous years. Basic questions from books, and then go to previous year. Previous years are very important for any exam. You can't expect yourself solving the questions of GATE exam while preparing for CSIR NET on the first hand. Okay, so firstly you need to solve CSIR NET and then go to GATE or related exams. So the previous years of that particular exam are very important to solve, and you can solve them 4 to 5 times even to make your concepts more clear. Previous years are very important. So first, know the syllabus, do a little bit of it, and then go to previous years to check yourself. That's what I'm repeating here. Check yourself by testing yourself and solving these questions. Yes.
Sure, ma'am. And another thing is, in the pure mathematics, in theorems, the statements is enough, or the proof, we should study the proof, ma'am?
Yes. Someone also asked this question related to proofs. See, important proofs are to be looked at, but you don't need to remember the proofs. You need to understand them, take out the logic from them, and just leave them. You don't need to learn the proofs. because you have got so much, this big syllabus to do. So don't learn these proofs, but sometimes these kind of proofs help you in solving questions. For some questions, these proofs help you in solving the questions. So that is very important to know which proof is important and which proof is useless for you. So don't even read every proof, but yes, important proofs are to be read out, and that's what you will, know by time. Maybe you're preparing by watching YouTube videos. So these YouTube videos will also help you in knowing which proofs are important, which are not. So during the time of your preparation, when you get experience, you will get to know about it, for sure, by experience.
The proof technique is important.
Exactly. The technique of the proof is important. And you can also figure out your own technique. And if you are having problem with books, I can suggest to you the website called math.stackexchange. I used to do 50% of my preparation from there, because the way they explain, those mathematicians are there, the way they explain is really easier than the books. So whenever you're studying from books, you need online resources like math.stackexchange, or maybe some YouTube videos like that if you're not taking coaching. And if you're taking coaching, your guide can help you really well. But still, math.stackexchange can give you really nice proofs. They have proofs related to every math topic, so you can go there and check it out. But try to stay in logic rather than learning the proofs. Yes.
Yeah, sure, ma'am. Thank you, ma'am. Meaningful lecture, ma'am. Thank you, ma'am.
Okay, thank you, Nanda Kumar. Others?
Hello.
Yeah. Yes.
Hello, ma'am. I'm Nishita Pendharkar from Maharashtra, and
Hello, Nishita.
I've just started for preparing for IIT JAM, and I wanted to ask what should be my strategy and how to cover theory part.
See, first of all, what students do, they cover the whole theory and then they go to questions. I will say that do one topic. For example, you did linear differential equation, first order differential equation, and the ways to solve this differential equation. Now go to PYQs, the previous year questions. And for IIT JAM, the related MSc entrances like DU entrance exam, BHU entrance exam, the previous year, and this year is going to be CUET entrance exams. Collect all these papers in hard copy with yourself, because you are not going to solve it with the soft copy of your computer. So collect all these papers in hard copy and solve these questions. And maybe you have 20 questions to solve related to your topic. Try to collect those questions topic wise, but if you're not able to collect them topic wise, try to pick one paper and just do the linear differential equation questions. And when you do that, well, you will easily find out the on the internet the topic wise questions also, if you do a little bit of hard work. So take those questions. If you have taken like 20 questions related to your topic, whatever topics you know, maybe sequence, series, or some linear topic or some differential topic, maybe 20 questions are there. Give yourself 60 minutes and try to solve them in 60 minutes. Give yourself a bounded time so that you can know how much time you take in solving those questions. So do one topic and solve questions of that topic, instead of just doing whole real analysis and then going for solving questions of real analysis. So first of all, do one topic theory and one topic question. That's what I will recommend. 1 or 2 topics, not more than that.
Okay, thank you, ma'am.
Okay, thank you, Nishita. Tidhi Biswas.
Yes, sir. Hello, ma'am. I'm Tirur Biswas from West Bengal, and I am an MSc second year student. First, I want to thank you for this wonderful session. It was very helpful as we are preparing for IIT JAM or NET, and I am preparing for NET exam. So it is a very helpful session for us. Ma'am, as you inform us that for clearing the NET, we have to solve the problem and do the more problem to practice. But after clearing the NET, we have to face the interview. So can you tell us about interview? That what would be the difficulties at the time of interview?
Titi, my connection was lost for. Can you ask Again, the question, what was the question? I couldn't hear you.
Okay, ma'am. Ma'am, I wanted to ask that after clearing the NET, we have to face the interviews. Can you tell us about the interview, that what is the difficulty level and what type of portion we should expect for the interviewer?
Okay, that's a good question. That's a different and good question. Let me tell you one thing. You need to start attending the mock test. How will you do that? I will explain you. First of all, if you have prepared enough for your CSIR NET exam, you can go for mock interviews. How will you go for mock interviews? If you have a study group of 4 to 5 friends, you study together and you all want to crack PhD interviews. First of all, let me tell you, the PhD interviews are not at all very difficult, except for those like institutes like CMI or DEFR. They have a little bit of difficulty level. They ask you proofs. But otherwise, if you go for, little like central universities or little less premier institutes, they will not ask you very difficult kind of proofs. So you can start yourself. You can start your mock interview preparation with definitions and little bit of proofs. For example, in group theory, you might have a little Lagrange's theorem proof. So how will you do this? You might have a 4 to 5 friends group, or maybe a 2-friend group. You can daily spend half an hour coming to an online meeting, and you and your friend can prepare one topic, okay? And then she can ask you, maybe she can ask you what is the definition of limit point related to what you have prepared. I'm not asking what will be limit point. If you're prepared for real analysis, or just keep your focus on 1 or 2 subjects, not more than that. Not everything is asked in interview. Your good topic, good topic will be asked in the interview. So maybe you're good at real analysis. She can ask you, maybe you'll say that I prepared for sequence and series. She can ask you questions related to sequence and series. And this will not only help you, but also will help her in asking questions and judging questions. And you can also, there are also online resources in which there are available questions that were asked in the PhD interview. Students do share these questions on these online resources. I won't name them. You can ask me after the session. So there are online resources and free resources in which they make you available the interview questions. And your friend can also ask you from that questions. And if you both are stuck in some particular kind of question, you can always take help from your senior or your teacher. How will I solve this question? This was the question I was, stuck in. So you can start attempting these mock interviews, 15 minutes for your friend and you. So to increase your confidence. First thing in any interview is your confidence. Some students are not even able to define limit point, even if they know. So confidence is very important. You can try it out. Okay.
Okay, ma'am. Thank you so much.
Thank you so much.
Okay, thank you, Titi. The method suggested by Unnati was really a very powerful method of combined study. So it will be very good if you practice like that. And of course, you can make use of all online resources which are available. We also, our group Math Aspirants are also trying to arrange some mock interview sessions for selected students in this year. Let us see. Okay, others. Yeah, now we have a bunch of resource persons like you, Unnati, so we can arrange such sessions, I think. I expect your cooperation in that type of events that we plan.
Sure, sir.
Okay, now others, if any of you interested to ask anything, you can.
Good afternoon, ma'am.
Good afternoon, Shikha.
Shikha, please introduce you.
Yes.
If possible, keep your video on.
If you guys can keep your video on, that will be more interactive. Okay, no one is going to judge you. Don't be shy.
Yeah, please others, also please keep your video on.
Yeah, I love to answer the question of, I think it was Titi. That was great interacting with her. Hello, Shikha.
Yeah, Shikha.
Hi, ma'am. Good afternoon, ma'am.
Good afternoon.
Ma'am, I'm Shikha, a second year student from Jharkhand. second year MSc student from Jharkhand. I would like to know that which book we should prefer for this autonomous differential equation.
For this, I don't remember exactly the name. There was Simon's book, I think. It was G.F. Simon's, or there was one more book. It was Calculus by Stewart. Stewart's Calculus is also there. But I will confirm the name of this book. You can message me personally after the session. I think you are in WhatsApp group. If you are in WhatsApp group, I will post there.
Yeah,
Okay, you are in WhatsApp group. I'll
yeah, Unnati, you can add the references in your notes that you plan to share.
Okay. Yes, sir. Okay, for sure. I'll do that.
And thank you. The session was really nice. Thank you, sir.
Thank you so much.
Thank you, Shikha. Thank you, Shikha. Okay, others,
Yes,
please
Alina.
keep your video on and talk.
Alina wanted to ask, I think.
Yeah, Alina. Yes.
She has left or not.
I am wondering why these people are this much shy.
Shy.
Am I audible?
Yes, Harita.
Yes, sir. Harita.
Hi, ma'am. Good afternoon.
Hello.
It was
Good afternoon.
Thank you so much for your efforts. Actually, I never thought that differential equations was this much fun. It was very nice session. I'm really thankful to you and Vinod sir for arranging such an opportunity for us. And ma'am, I'm final year student of BSc Mathematics from Kerala. I wanted to ask how can we manage the time? We have to do all these things in together. I'm preparing for JAM actually. So, do you have any tips for us in time management?
I think my short tip for you will be, I have taken a session on, I do take online sessions on how to manage time, how to stay fit, things other than studies, because I believe not just studies, but also these other things that keep you fit and mentally healthy are also important. So I've taken a session on how to manage time, but I will answer you in short. Don't ask for time because everyone has 24 hours. Yes, sir. Are you saying something?
Yeah, Unnati, we can also plan such a session for our students.
Yes, sir, for sure. But maybe not possible next week, but next to next week we can think about it. I'll let you know, sir. So, Harita, I was saying that don't ask for time, ask for focus. Because in today's scenario, we're not lacking time, we're lacking focus, because that little phone of yours is the kind of thing that's creating distraction for you. You study for half an hour and you use your phone for like 1 or 2 hours. I'm not talking about you, I'm talking in general. I know most of the students are really focused, but that phone is creating problem that, first of all, you need to delete all the distractions from your life. Whenever you're studying, just study, okay? And try to make a list a night before what you need to do the next day. So make a list a night before, or just wake up early and make a list. These are the things that I will have to do. You can make it on paper or maybe on Google Calendar, but I will suggest on paper so that you don't get distracted by seeing Google Calendar every time. Try to see where, if your time is going in, these kind of distractions like watching reels or YouTube videos or things like that, scrolling social media, answering messages too much, or maybe attending too much phone calls, sometimes it is. So try to do these things. I know you can't skip those classes which you have in your final year completely, but obviously you can do these little changes in your life and for sure you can manage time. Okay, I can't answer it in a very big because we are in short in time, but yes, these are the tips that you can follow.
Yeah, definitely, Unnati, we can plan such a session. I think that will be more useful for our students. They are really fed up with all the university exams, internal exams, and all that.
Yes, of course, of course.
Thank you, Harita. Okay, others.
Hello, ma'am.
Hello, Alina. I see that you have been trying to ask your question from last 10 to 15 minutes. Hello.
I just wanted to thank you for conducting such an interesting session, Especially the question discussion was very detailed and clear, so it was easier to understand. So thank you, ma'am.
Thank you so much. Thank you so much, Alina. And I also thank you, Vinod sir, for letting me be here and be able to connect with such a big audience.
Okay, thank you, Alina. Any others? Anamika, are you there?
Hello, ma'am. My name is K. Abarnalal. I'm from Trivandrum, like Kerala. First of all, I want to thank you for for giving us a wonderful lecture on differential equations. It was very good, and I really enjoyed it. And it gave me new insight to how to study all these things. Thank you, ma'am. Then I also want to thank you, sir, too. Sir also, Vinod sir. He gave us he gave us an opportunity to study this. So thank you. I just want this time to thank you too.
Okay, thank you, Aparna.
Thank you,
so
Aparna.
much.
Gopika? Any others?
Yes, guys, please, you can ask anything. Well, you can ask anything from me. My domain is not just related to these maths exams. As I said, I keep conducting these sessions which are related to your self-growth.
So I think almost their data maybe they have shortage of data. I think many people are
Okay, sir.
as it is around 2.5 hours now.
Yes, sir.
around.
Yes.
Ma'am.
So let us find it. Yeah. Yes.
Ma'am.
Yes,
I am
Abdul.
Abdurrahman from Kerala. Please share your experience when you was like our time, first time preparation for any exams. When you like our age.
So I was a struggler. I was never a very good student because I could understand questions, but I wasn't a very hardworking kind of student. So I prepared after MSc. I'll be very honest, because until MSc I didn't have an idea of clear idea of what I'm going to do. So I started preparing for CSIR-NET after MSc. And yes, when I started preparing, we had this group of 5 to 10 friends where we used to discuss daily. So maybe you guys should learn from us that you need to discuss some questions, maybe 10 questions or 100 questions, doesn't matter. You should discuss it with your friends, because discussion always increases and opens your mind. And it did for us. We were not a very, very great students, but all of our friends could clear NET exam and GATE exam. So it helped us really well. And, that is what I can tell you about my preparation. That helped me a lot, and that also can help you guys. Yes, Abdul.
Okay, thank you, Abdurrahman. The peer group interaction is very much important in any study, especially while preparing for competitive examinations. And
Thank you, ma'am.
through
for
our
your
Maths Aspirants
time.
Groups, we are trying to arrange that. Yeah, thank you. Yes.
Thank you so much, everyone. Thank you so much.
Yeah,
It's been a great opportunity for me also.
Yeah, let us wind up here. Once again, I would like to thank Unnati for your valuable time spending with Maths Aspirants Groups. So thank you, Unnati. Let us wind up. Thank you. Thank you, everyone.